Imagine that you have to do your day-to-day activities with these voices in your head. Quite challenging, right? Well, what you just have experienced is what people with schizophrenia and bipolar disorder go through. It is estimated that around 4% of world population suffer from these psychotic disorders. And in Australia, the overall yearly cost of treatment and disability is around 2.6 billion. We're aiming to know what's wrong in the brains of people with these psychotic disorders. But doing this research is like imagining the brain as if it was a microscopic crime scene. In a real crime, we look for people, but in the case of a brain crime, we look for cells. So identifying the victim of the crime is vital. And in the case of schizophrenia and bipolar disorder, we know that one of the main victims are the dopaminergic neurons found in the midbrain. These neurons produce a chemical called dopamine that, as some of you might already know, is a neurotransmitter that regulates motor functions, cognitive functions, and is heavily dysfunctional in these psychotic disorders. All right, so we have identified the victim and the neighborhood in which this crime could have been taking place. So what about the suspects? Well, in our lab, in our team, we believe that one of the main suspects in this crime against dopaminergic neurons are inflammatory immune cells derived from the blood or from around the blood vessels. Normally, these immune cells are key defenders of the body against infection or disease. So, as Sherlock Holmes in a crime scene, the aim through my PhD has been to explore using human brain tissue and different cellular and molecular techniques to explore how close these immune cells can get to dopaminergic neurons and which molecular weapons are they using in this crime. So far, we have found increased number of these immune cells and increased activity of them and activation of cell death markers in the midbrains of people with schizophrenia and bipolar disorder that are highly inflamed. We have found that when these inflammatory markers are up, the dopamine markers are down, suggesting that, indeed, these immune cell suspects are using some cell death molecules in the crime against dopaminergic neurons. We're not sure yet if these immune cells are affecting or damaging the dopaminergic neurons directly or their surrounding environment, creating a hostile neighborhood in which dopaminergic neurons cannot thrive. We still not sure yet if they have accomplices. So far, we're also exploring currently the role of glial cells, another immune cell that normally bring brain support. Are they silent bystanders or conspirators? In summary, we have evidence suggesting that immune cells are key suspects in the crime against dopaminergic neurons in the midbrains of people with schizophrenia and bipolar disorder. Defining the criminals and the molecular weapons that they're using to commit their crimes is vital to stop their tracks in the future. So resolving this crime is, as Holmes would say, elementary, my dear Watson, because it will allow us to know which cells to target to get better treatments and improve the quality of life from thousands of people. For example, reducing the auditory hallucinations from thousands of people suffering from these psychotic conditions. Thank you.